In this video, we're going to do some proofs with some modulus operators. So, for the first one, we want to show that for integers a, b, and m, if a and b are congruent modulo m, if and only if there exists a k such that a is equal to b plus km. So, essentially this means, so a and b are congruent modulo m, this would mean that a is equal to b mod m. And what our end result is that we can write this as a is equal to b plus km. So this is an if and only if proof. But what I'll do is I'm going to work it from left to right, and then right to left are just the same states, or same steps. Okay, so a is congruent to b mod m. This is the same thing, by definition, as saying that m divides a minus b. So this is by definition. Okay, so what does this mean? This means that there exists some k such that k times m is equal to a minus b. Okay, so again, this is by the definition of division. And the first one is by definition of the equals mod m operator. Okay. So at this point, we can just rearrange terms. So we can move the b over to the left side. So we're going to get b plus km is equal to a, and that's exactly equivalent to our last line. So if you go down, then that is the left to right direction. If you work up, that is the right to left direction. So that is the proof that if they're congruent modulo m, then you can write 1 in terms of b plus km. Okay, so this makes sense because we're saying this integer a is just equal to the number of times it goes in properly, so that's b, plus k times m, so this is kind of like the remainder. Okay, so with that being said, let's prove something more. So if a is congruent to b mod m and c is congruent to d mod m, then a plus c will be congruent to b plus d mod m, and a times c will be congruent to b times d mod m. So let's prove the first one here. So we have a is congruent to b mod m, so we know we can write this as a is equal to b plus km, and we can write c equal to d plus jm. So last time we proved that we can do this. They are congruent to each other, so we can write them in terms of b plus k times m. Okay, so we want to show that a plus c is equal to b plus d mod m. Okay, so a plus c is the same thing as b plus km plus d plus jm. So let's move together like terms. So let's move b plus d together, and then km and jm, let's put those together. So if we do that, we can factor out a k. So now we have that a plus c is equal to b plus d plus m times k plus j. Well, because of our proof earlier, this implies that a plus c is congruent to b plus d mod m. And it's the same formula. So before we had a is equal to b plus km. Well, here's our a. Our a is a plus c. Our b is b plus d. And our k is our k plus j. It follows the same formula. So we're good there. Now let's do the proof of 2. So we want to show that a times c is congruent to b times d mod m. So ac, well, this is just going to be b plus km times d plus jm. So let's multiply this out. We're going to get bd plus bjm plus k dm plus kjm squared. Okay, so let's factor out an m from everything if we can. It's going to be m times bj plus kd plus kjm. Oh, look, same thing we had before. A is equal to b plus m times k. So, because we have all that there, we know that AC is congruent to BD mod M. So those were 2 proofs. If you'd like more proofs with congruency, then please let me know. I think these are something that I haven't really done in the lecture videos, so they're pretty good to use to learn. So if you have any questions, leave them in the comments below, and I'll answer them the best that I can.